Hello, this is our week 2, day 2 reflection video for our algebra boot camp, and it's also our day 3 preview video, and that it shows us what we're going to be covering tomorrow. And you'll notice this equation is more complicated than the ones that we've been doing. It has parentheses in there, so it's going to involve distribution. And actually, this equation goes through all the steps of our DSID model. And we're going to be focusing on the first two, the distribution and the combined like terms, so you can see how that starts off and how that goes. And then the isolate and divide steps that we've already learned would just be the same as the ones that we've learned previously. And actually, I'm going to relate this to how we've done it before in the sketch method so that we can see how it's similar and how those come together, and there actually ends up being the same answer either way. When we did the sketch method and how distribution really works, when we did the sketch method, what we found was when we've got parentheses, we actually sketch, and we start on the left and go to the right, but we sketch what's inside the parentheses. We don't sketch that number 3 on the outside. The number 3 tells us how many of what's on the inside we need. So the inside is what I'm going to sketch, the 2 x's and the 1. And I'm going to sketch it down here. So I've got 2 x's. X's are our triangles. So I've got 2 triangles and a 1 cube. And that makes one set. The number on the outside here, this 3, that tells me how many sets I need. I've got one set, I need 3. So I'm going to do a second set, and then up on top here I'll do the third set. So I got 2 triangles and a 1 cube, 2 triangles and a 1 cube. Now I've got 3 sets of that. And then I just keep going to the left. The next thing is this 2x. And it's not a part of the set, so I don't need to do it 3 times because it's not inside the parentheses. The sets are what's inside the parentheses. So this is just a 2x's. So I'm just going to, like, off to the side here, do 2 more x's, 2 more triangles. And then on the right side, I've got 4 x's, so 4 triangles. And this 12 constant, that's a 12 cube. So this is a representation visually of what we've got here. And you'll notice what we've got as far as our sets go. I'm going to point this out. We've got 1, 2, 3, 4, 5, 6 triangles. So that would be like 6 x's. And then 1, 2, 3, a 3 cube. Now we're going to see how that relates to the distribution algebraically. Because when we distribute algebraically, we're actually multiplying. Distribution step is a multiply step. So I'm going to multiply the number outside, or if it's a letter, but whatever's outside to whatever's inside. And make sure I do it to everything inside. So my first step would be to go, okay, 3 times 2x. And you can only multiply the numbers. The letter just comes with it. So 3 times 2 is 6, and then the letter comes with it, 6x. So 3 times 2x is 6x. And then I do the 3 times the 1. And 3 times 1 is 3, and since it's positive, I'm going to do a plus 3. I don't multiply to the 2x on the outside because it's not a part of that set. So I'm just going to write it down because I haven't done anything with it. And then on the other side, I've got my 4x and the 12. That is the distribution step. And you'll see it follows along with what we did in our sketches. We had 1, 2, 3, 4, 5, 6 triangles to start, and I've got 6 x's. And then 1, 2, 3 for a 3 cube, basically, and I've got a 3. And then I've got 2 more x's. So I've got 2 x's in my algebraic method. And then 1, 2, 3, 4 x's in a 12 cube, just the same as the 4x plus the 12. So either way it can work, whether you want to do the sketch method or use the distribution with the multiply. Just make sure you're only multiplying what's outside the parentheses immediately on the left to what's inside. Now we're going to look at that combined step. And if I count up all my triangles, I'm going to change my color to green so it's more obvious. I have 1, 2, 3, 4, 5, 6, 7, 8 triangles. And I can redraw them if I want to make it more obvious that I have 8. And then I've got 1, 2, 3, like a 3 cube. On the other side, I just still have my 4 triangles and a 12 cube. Now, if I try to go back to the combining like terms step that we learned today, I know that I can put my 6x and my 2x together because just like the triangles are the same, the x's are the same. They're like terms. So 6x plus 2x is 8x. That 3 does not get combined. It's a constant, so I'm just going to write it down. And then I've got the 4x plus the 12 on the other side. So now I've got the same thing both algebraically with 8x's plus 3 equals 4x's plus 12 as I do down here showing with the sketch method, and that's the combining like terms step. After that, you would isolate using addition and subtraction, and then divide if you need to. But this just sort of shows you how the division step and how the combining like terms step work when you have to do them for these more complicated problems.